20 minutes before midnight. Definitely enough time to build another vessel. This time we will take a look at how can we build a vessel that has not a cylindrical shape, but is elliptical and has some interesting flow transitions. So one of the problems the elliptical shape provides us is we cannot use the revolve command, because with the revolve command, as you can see, you will get a circular cross-section or profile. So how do we build this bottle? This is actually also a really nice study object to demonstrate how you should always take a look at an object in general and try to see the geometrical building blocks. So for example, this looks like an elliptical shape which is extruded. This is a cylindrical shape which we could extrude or could revolve. This is a very organic flow. So this is not something we would do by hand. We would calculate this. And then down here we have another interesting flow surface or blend surface. Very good. Okay, so let's make a new design. We make sure this is in millimeter. Very good. And we will start by creating an offset plane here, and then we move this one up 18 millimeters. Then create a sketch on it and go to ellipse, click on the x-axis, click on the y-axis, click. Very good. Then press D. Oh, we go dimension. So this will be 82 millimeters, and then this will be 66. Okay, so now we actually created this ring down here, and we could extrude this body up. Okay, let's go to solid, extrude, and extrude this one 104 millimeters. Now you might ask yourself, why did I actually start with this middle piece and not with something on the ground? That is actually very true. You could have done something on the ground, but you will see why I decided to start with this one. It's also a very simple shape, so it was very easy to position and define. The next piece I will do is actually the top part. So there are now actually two ways how we could do this. From here to the start of the cylinder should be a distance of 42 millimeters. So I could make a sketch, and then I know somewhere here I need to have this rectangle, which then I could revolve. That's all good. That's a doable way, possible. I delete this sketch because I would like to actually show you a different way. Not necessarily to say the different way is better, but simply to show you how interchangeable these commands are. So from this face to where the cylinder starts has to be a distance of 42. So we know, okay, hey, with this offset command from this face now, not only from the ground, I can move up this by 42 millimeters. Cool, no? Okay. So now there I can place a sketch, circle, D for dimension, 30, finish sketch, and then we repeat the same command, extrude by 26. Very good. Okay. And there now you can see these are the two most brutally simple elements. Now I can start to think about, well, how do I do the transition from here to here? And how do I do the transition from there to the bottom? Welcome to Loft. So far we learned that revolve rotates, extrude, well, moves it one direction, and loft, think about it as a blend. So click loft, click this one, click this one, and then we get this transition. You see it goes from an ellipse to a circle. Wonderful tool. Let's take a look at the features here. Profile 1, profile 2, connect G0, G1, G2. What does this mean? G0 means this is a linear connection, so it means just at this point. Tangent means the surface, let's take a look, blends actually tangentially. When we zoom in a little bit more, what we see here is a linear surface, and from here instantly it blends. This looks properly for beginners, really nice, but this actually is not a nice and soft or smooth transition. When we go to G2, you notice that this is a little bit longer, so the surface goes straight up and then continues and then slowly blends. So a much nicer flow. Let's take a look at this. We will go to here and go to shaded and then rotate our camera. Pay attention to that highlight. It's a small ball and now it gets into a line. No? Okay. Double click on this feature. Well, let's set this to G1. Do you see actually there is an edge here? There, you can even see that. Because the highlight now from a cylinder instantly goes to a highlight of this blend surface. So, and that is why I in design hardly ever use G1, basically exclusively use G2. However, G2 is more complex to calculate, so very often I set it to G1 and later go to G2. This is a very simple object. We can keep this on G2. Very good. Now you see much better. So let's actually get this back. And now when we click on profile here, or also there, you see there are arrows. What are these arrows? Well, let's click on it. Oh, interesting. I can shape the flow of that transition. Make this shorter. Make this longer. Very interesting. Also here I have a weight. So 1 is the standard weight, or I make it shorter, below 1, or make it longer, above 1. Very good. This operation is also set to join, so it will fuse this blend surface to these two objects. There you see one body. Cool. Okay, that looks actually really nice. And you see when we rotate around, it's a very even and beautiful transition. So how do we now get this bottom detail designed? Also very easy. 2 ways. Let me hide this, turn this on, turn this off. So here I have the sketch. I could now go ahead, go to here. So this is looking from the bottom, and then create a new ellipse. And then I know, okay, so this was maybe 82. Yeah. And this was it maybe 60. Let's see. No, it's not. So now I would have to go back into the first sketch, try to remeasure it, and see, a little bit too much work. So definitely doable, but not good. So how could I replicate this ellipse inside this sketch? Well, we have a project command for that under create project. Move your mouse onto the ellipse or see this line or this point and click. And now we have a magenta line. That's actually really nice. What we can do now is we can offset it by -6 to the inside and enter. Let me give you a demo of what parametric modeling means. Here's actually our first element. I will right click, say show dimension, and I switch this to 60. You see how this adjusted, then this adjusted. 66. Beautiful, now because from where I created this first sketch, everything was updated. So this way I can create an ellipse that is always 6 millimeter offset from this original ellipse, or if we take a look from the bottom, basically it is 6 millimeter inwards from the outside of our vessel. So step number 2, I will go to create and then loft and now say U to U connect direction. No, that's not what I want. What is class actually looking for? You notice there's no G1, G2 or so. Okay, escape. See, here's one sketch, second sketch. Under the sketch is also the face of this cylinder, so I might want to hide the sketch. This is a very important step or process for beginners to understand. Very often they overlook it. Now I can select this face and loft from this face to this ellipse. Zack, zack. And if I go to profile 1, there are my commands. G2, go to front view, push this down a little bit more. Yeah, beautiful. That looks really nice. How it basically from this outer ring then blends to this ring. Now this is a flat surface, and there I would like to create a small dome in. I could make a new sketch basically on this ground, projecting this edge of the geometry in. I will, however, go to this original sketch, double click, and go offset. You cannot offset from an offset element, so we have to go from the original projection again, and then we say -12. Enter. Very good. Finish. Now I have this thing here, and I would like not to necessarily loft this up. I can actually also taper it, by the way. Oh, that's pretty cool. And that's not really what I want. I want this to be nice and domed. So let's delete this extrude feature. To dome it, I can use the loft command. So this profile could loft, but I need a stand, or not a stand, a target point. So let's go to a side view, turn this off, new sketch on a vertical construction plane, and create a point. I will put the pointer here again to show you and give you good practice for how important it is to make sure things are vertically aligned. Sketch dimension, click, click, and 10 millimeters. Finish. Then all this we can turn off besides this one. You can see this. Okay, now we will loft this inner profile of the sketch to this point. Click. Because this is lofting into the volume of this bottle. You see it's red. It will cut the space out. But it cuts it actually like a dome. That's not what I want. Take a look here. Sharp. Tangent. In this case here, we only have tangent, and we can make this a little bit more bulky or smaller. We'll go with 1.2. Yeah, that's good. Okay. There. Easy peasy. Now this is maybe too high. 1 centimeter. Bring this down 5 millimeters. Easy. Here, that's the sketch for the point. For example, we call this one loft bottom target. This is maybe loft, or not loft. Yeah, no, yeah, loft bottom. And this is actually cap. And this is ellipse base. I simply made these names up. I don't give the body a name. Sometimes it changes, but sketches to be named makes really sense. So here's my target sketch. Very good. Right click, show dimension. Yeah, 10 is too much. 5. Yeah, that looks better. Maybe this is too flat there. Double click, change this to 1. Oh, this is less domed. Maybe 7. Sweet. Okay, very nice. Now, as a basic study for a bottle, this is good, but this should be a neck. How can we now quickly from this shave a cap out? I said neck before, I mean obviously a cap. Okay, so in this case, we will use the revolve command. So new sketch onto here. And I would like this neck basically to start where this line is. Again, I said neck, I mean cap. It's getting close to midnight. So from here, I need to be able to draw something. Well, it's actually now easy. We can go to project, and I go into a 3D view. So you can see what happens. When I click on this edge or this face, you see how there are lines popping up. Click, click, okay, hide this, and look at that. So the edges of that element got projected in. Now again, little demo about parametric modeling. You see here, this creates this cap. Double click. 15. You see? Follows it. 26. Cool. Okay, so double click on the icon here. Now we can make a line. This is the midpoint, go straight down. To the left, go straight down. Very good. Beautiful. Then we will specify the dimension. This thing here, we'll give this 2 millimeters. That is fine. This here, we will give this 1 millimeter. So we make this smaller. And we would like to have a little bit of a gap. There has to be a threading. So I do not on that midpoint. I draw a line here on purpose, a little bit crooked, again to show you to make this straight. D for dimension, U to U. Let's say 1 millimeter, that's not enough. 2 millimeters for a gap, because we have a threading that has to go in there. Very good. Okay, so there is the piece. And let's check this out. We go revolve. Then click this and this. Okay. And then we can go to select the axis. Here's my axis. And cut this space away. Very nice. Revolve one more time on this. Select this axis. But down join, make a new body. Now there we have the cap. Cool, no? Yeah, I think so too. Little finish. Small fillet. Okay. Then plus U in U5 or 4. You see how the fillets there are a little bit different. 3. So I would like this to be the same. So do this accord. Okay. And this one actually changed back to constant. Very good. But down here, sometimes the interface can be a little bit annoying. You notice how I needed to click into various areas. So 2 millimeters. You see, this is now really each 2 millimeters. That's nice and good. Okay. Yeah, we can keep it like this. Okay. And that's then the moment where we can shell this 2 millimeters. We also have the cap. Let's make this less ugly. At least a fillet. 1, 2 millimeters. Constant is fine. Let's go to back view and let's do a section analysis. Yeah, that looks actually pretty good. So there's the gap where we could put a threading into, and the rest all looks actually pretty peachy. Good. That's it.